Hello friends, in this video, let us discuss about the binary search algorithm. So in the previous video, we learned about linear search algorithm. It was like a book with unordered pages. And to get any particular page number, we had to check each and every page from the beginning to the end till we find it. So binary search is actually like searching a page in a book with ordered page numbers. Here, the first page number will be 1, next will be 2, then 3, then 4 and so on. So assume you have such a book in your hand with 100 pages. And I am asking you to find page number 90. So what will you do? You will take the book and open the page near to center. Now you have the left half and right half. So we know we have 100 pages. So in the first half it will be 1 to 50. The second half it will be 51 to 100. So you will ignore the first half and consider the second half only, since 90 could be present in this half only. And here the page numbers are from 51 to 100. Again you will divide it in half and it will be 51 to 75 and 76 to 100. And you will ignore the first half again and search in the second half. And this way you can easily find the page number 90. So unlike linear search, we don't need to go through all pages of the book. We will continuously divide the book into halves till we find that particular page. So we can save a lot of time. So that is binary search. So binary search can be performed on sorted or ordered set of elements. Say this example array with elements 10, 23, 45, 70, 100, 111 and 123. Suppose we want to search for the key 45. So as we did for the book, we will first find the middle element. We have 8 elements, so the fourth one is the middle one, which is 70. It is not the key, and now we have to check if our key is less than or greater than 70. And it is 45 less than 70. So it could only be present in the left half. So search here only and ignore the second half. Again, in this half, the middle one is the second element 23. Again check whether 45 is less than or greater than 23. It is greater than 23. So check in the right half only, and here we have one element and it is our key. So this is what binary search is. Now let us see its implementation in C. So we have the function binary search here, which will take the array, its start, end and the key to be searched into it. And it will return 1 if the key is found, and it will return 0 if it is not found. So we pass this array, its start index 0 and end index 7 and key 45 into the function and declare a variable mid. And we have this while loop here, which will divide the array into halves till we find the key or the array is completed. And when the key is found, 1 is returned, and when the array is completely checked, this condition start less than end will fail and control comes out of the loop and returns 0. So let us see. In first iteration, start 0 is less than end 7. So go inside and find the middle element. So we have mid equal to start plus end divided by 2. That is 0 plus 7 by 2, which is 3. Now check if the middle element is the key. So we have if ARR of mid equal to key, and it is not. So check whether we should search in the left half or the right half. So we have if ARR of mid less than key, and it is not. So 70 is actually greater than 45. So we should only check in the left half. So start should be the same index 0. But end should be mid minus 1. So in else we have end equal to mid minus 1, that is 3 minus 1, which is equal to 2. Now check the condition again. We have start 0 less than end 2. So the condition is okay. So go inside and find the new middle element. So we have mid equal to start plus end divided by 2. that is 0 plus 2 divided by 2 which is equal to 1. So check if middle element is the key. And we have ARR of mid equal to key, but it is not. So next step is to find the half where key could be present. So check if ARR of mid is less than key and 23 is less than 45. So we should check in the right half only. So end will be the same, but start should be mid plus 1. So start equal to 1 plus 1 which is equal to 2. Now check the while condition and 2 is equal to 2. So the condition is okay. So find the new middle element. It is 2 plus 2 divided by 2 which is 2. Now check if middle element equal to key, and it is. So return 1 as the key is found. This is how it works, and always remember binary search will work only for sorted arrays. Now in the same array, let us search for the key 150. So first find mid, which will be 0 plus 7 divided by 2, that is 3. Now check if middle element is the key, and it is not. So check whether to go to left side or right side. So we have if ARR of mid less than key and 70 is less than 150. So we should check in the right half. So end will be the same, but start will be mid plus 1, that is 3 plus 1 which is equal to 4. Now check the while condition and start 4 is less than end 7. So go inside and find the new mid which is 4 plus 7 divided by 2, that is 11 by 2 which is equal to 5. So middle element is at index 5. So check if it is the key. So we have if ARR of mid equal to key, and it is not. So check if ARR of mid is less than key and 100 is less than 150. So if the element is present, it could only be present in the right half. So set start equal to mid plus 1, that is 5 plus 1 which is equal to 6. Now check the condition and 6 is less than 7. So go inside and find the new mid, and it will be 6 plus 7 divided by 2, that is 13 by 2 which is equal to 6. So check if it is the key. So we have if ARR of mid equal to key, and it is not. So check whether to go to left side or right side, and we have if ARR of mid less than key and 111 is less than 150. So it could be present in the right half only. So set start equal to mid plus 1, that is 6 plus 1 which is equal to 7. And check the while condition, and 7 is equal to 7. So condition is okay. So go inside and find mid which will be 7 plus 7 divided by 2, that is 7. So check if that is the key, and it is not. So check whether to go to left or right. So we have if ARR of mid less than key and 123 is less than 150. So 150 could only be present in the right side. So set start equal to mid plus 1, that is 7 plus 1 which is equal to 8. Now check the while condition, and 8 is not less than or equal to 7. So the condition fails. It simply means we have completed checking the array, and now there is no chance that the key is present in the array. So control comes out of the while loop and returns 0 as the key is not found. Now let us discuss about the time complexity of this operation. So we have this array and we are searching for key 70, which is the middle element. Then it can be found in the first comparison itself. So the best case time complexity is order of 1, and it will be when the key is the middle element. Now again, we have this array and we are searching for key 45. So first there are n elements. Then we find the middle element 70 and understood that the key 45 could be present in the left half only. So now we will consider only n by 2 elements. Now we will find the middle element here, which is 23, and 45 could be present in the right half only. So now we will consider only this part, which is n by 4 elements. That is, this algorithm is dividing the array into half in each iteration. That is, first we have n elements, then n by 2, then n by 4, then n by 8 and so on till we have just one element. That is, n by 2 raised to 0, n by 2 raised to 1, n by 2 raised to 2, n by 2 raised to 3 up to 1. That is, in general, n by 2 raised to k equal to 1. So n equal to 2 raised to k. Now let us take log on both sides and we will get log 2 raised to k to base 2 equal to log n to base 2. And by theories we can write log m raised to n equal to n into log m. So we will get k into log 2 base 2. The value of log a base a equal to 1. So value of log 2 base 2 is also equal to 1. So we will get k into 1 equal to log n. So the average or worst case time complexity of binary search is order of log n. Now let us have a quick comparison of the time complexity of linear search and binary search. If we have this array and key 123, we have to make 8 comparisons checking each and every element in order to find it in linear search. And the worst case time complexity is order of n, that is order of 8 here. And in binary search, the worst case time complexity is order of log n, that is order of log 8, which can be written as 2 raised to 3. And it can be written as 3 into log 2 base 2 and value of log 2 base 2 equal to 1. So 3 into 1 equal to 3. And for array of 8 elements, linear search takes 8 iterations but binary search takes only 3 iterations. So that is how binary search is very efficient than linear search. But we always need a sorted array in binary search. If the array is sorted, then we can undoubtedly go for binary search. And if we have an unsorted array, and to apply binary search we have to sort it first, then pass it to binary search function. So it may not give that much efficiency.